So the past few days we've been talking about sequences. So I introduced to you guys the concept of arithmetic and geometric. We talked about the formulas for the various sequences, and then we did some problem solving with our sequences as well. On our very first day, so a couple days ago, I did define for you guys a series, but I just touched on it briefly. So we know that a sequence, actually, why doesn't somebody explain to us, what is a sequence? We've been working with them for the past few days. So could you explain to me what that is? Okay. Okay, so an ordered list of terms that change by a constant pattern, we'll say. Oops. Okay, so we do know that we have two types of sequences. We have arithmetic and geometric. There can be other sequences as well. These aren't the only types of sequences, but these are kind of the main ones that we're working with. So where we have arithmetic, we're adding a consistent or subtracting a consistent value to get future terms. Where we have geometric, we are multiplying a consistent value to get future terms. Okay? For a sequence, you will see the ordered list of terms separated by commas, usually. And then now we're getting into some series questions, and a series is kind of based on a sequence, but it's the terms of a sequence added together. So sometimes when you see like a list and it's talking about a series, you'll see plus signs in between all of them to show that addition is happening. So we kind of usually refer to this as a series is the sum of a sequence. Okay, and because the series is a sum of a sequence, we can have arithmetic series and also geometric series because it's just either the sum of an arithmetic sequence or the sum of a geometric sequence. So I can also have arithmetic with this, and I can have geometric. All right. So today I'm just going to kind of introduce the basic formulas to you guys. We'll do a few more like knowledge-based type questions. Guys? Excuse me? No talking. Elton, can you slide all the way over to the window, please? Okay. So, S4. When we say S4, we are saying the sum of the first four terms of the sequence. Okay, so what I could do is I could use my formula here, and I can plug in T1, and then T2, and then T3, and T4, and find the terms. But I think in plain English, we could kind of figure out what this sequence is doing based on the A and D values. So what does the A value tell us about our sequence here? Okay, and then what is the D value telling us? Okay, so we add 3 each time, right? So the next term is 4. The next term after that, we add 3 again, it's 7. And the next term after that, we add 3, and it's 10. So if I want to find S4 for this sequence, I'm going to sum those first 4 terms. I will do 1 plus 4 plus 7 plus 10, and then we'll just get our final. Okay, so I think here we get 22. Okay, so that's all well and good if we're just doing the sum of the first 4 terms, but what if I'm doing the sum of the first 50 terms? I don't really want to write out the 50 terms, and I don't really want to have to add those all together, because if I make one mistake, if I do one mistype in my calculator, I'm in trouble, right? So that's where our formulas come in. So for sure, like we could definitely solve a problem this way if it's like pretty easy to solve, if it's just like 4 terms or 5 terms or whatever. But if it's more, we'll want a formula that will help us out with this. Okay, so let's start with arithmetic for today, and then we'll do geometric a little later in the lesson. So we have Sn, which is the sum of the first n terms Okay, so if it's 7, we have the sum of the first 7 terms. If it's 10, we have the sum of the first 10 terms, and so on. Okay? Let me say right here. No problem. Okay? N, A, and D are the same things as what we used before. So N is the term number, or the number of terms that we're working with. A is going to be the value of the first term, and D will be that constant difference value. Sometimes we also have a secondary formula, which kind of comes from replacing part of this formula up here with Tn. So if you notice here, I can actually split this upper area up into, if I have 2a, I can express that as a plus a, and then n minus 1 times d. And this part right here is actually equal to Tn. So my secondary formula here is actually that we could have Sn equals n over 2, and then just a plus Tn. Now, each of these formulas is going to be useful for different scenarios. So this is my first formula here, and that's my second formula. This one is useful if we know the first and the last term of the sequence. So if I know the first term has a value of this, and then if I want to find the sum of the 50 terms, and I know the 50th term, the value of the 50th term, that's when this formula will be useful. But for the most part, we're going to use the first formula there. Okay. This one's going to be useful if you just know the usual information, like you know the first term and you know the constant difference value. You will probably find if you go to use maybe one of these formulas and not the other, you might not have the information you need to plug into that, so that will probably tell you, oh, I should probably use the other formula. So that can happen sometimes. Can I flip? We're good? Okay, so I'll show you kind of a few examples of how we can apply these formulas. So for this series, so we'll notice that usually we would see this as 1, 3, 5, and so on. This one's showing it as a sum, so we know it's a series. But some questions might show you the sequence, and then it will just say find S10. So that is perfectly acceptable as well. We'll just sum the series. So for our series, find the sum of the 23 terms. Could I write out the 23 terms and add them all together? I could. It might be quicker for me just to use a formula though, especially if it's like higher than this. So I have an a value of 1. What else do I know about this sequence that we're adding together? Isabella? Great. So the d value is 2 because we're adding 2 each time. And S23, I don't know, that's my question mark, but I do know that the term number that we're looking to sum, or the number of terms that we're looking to sum, is 23. Do I know the value of the 23rd term? I do not. So when I'm thinking about which formula is the better formula to use here, if I don't know the value of the last term that I want to sum up, I'm using this first formula up here. Okay? Ladies, let's focus in here, okay? So I'm going to plug into this formula. So S23, anywhere you see an N, you sub in 23. My A is 1, and my D is 2. And then we're just going to calculate. Okay, so I'll give you a second to calculate that up. Okay, anyone have an answer for us? Alexandra, what'd you get? 529. Anyone else? Yeah, great. So 529, that's the sum of the first 23 terms of this particular series. Great. Okay, so another version of this type of question that you could get with arithmetic series is that you have 52 terms, so I know the number of terms is 52. It starts with -7, that's telling me my A value, and ends with 102. So that means the 52nd term actually has a value of 102. Find the sum of the series. So in this case, I'm looking for the sum of the 52 terms. That's my question mark. In this case, I can actually utilize that second formula that I showed you guys because I know the first term and I know the 52nd term of that series. So I can actually use this Sn equals n over 2 times A plus Tn. Because when I plug in 52 here, I'm going to be looking for T52. So I would be saying T52 there, and then I know the value of T52 is 102. Okay, so we can just calculate from here. We'll get 26. Yeah, Isabella? Yep. Joey?
Will you give us these equations on a test?
I will, but you need to know what each of them is for. So I'm not going to like label them as arithmetic series, sequence, and all that stuff. Liam, what'd you get?
2,470.
2,470.
Yeah.
Anyone else get this answer? Yeah, great. Okay, any questions on these two examples here? Essay. Yeah, you'd have to know the last term of the sum that you want. Like if I want to know S50, I need to know term 50 as well, the value of term 50. Okay, otherwise we're deferring to probably just using this first formula here. Okay? And again, if you choose the wrong formula, you'll find you don't have enough information to plug in. Kendall?
So then is the S, whatever, giving you all of them added together, or is it giving you just the
Yeah, so it's actually giving you, like we know the 52nd term is already 102, so it's giving you like literally between -7 and the sequence that we would be created by doing that, getting to 52 as one, or term 52 as 102, it's adding all those terms in between together. Yep. Okay, good? Okay, so let's go over to geometric here. Our geometric series, this is our last kind of major formula for this unit. Our geometric series looks a little bit different. All of these things are the same things as we know and love. So Sn is the sum of the first n terms, just as it is in the arithmetic series formula. A is our first term, R is our multiple, and n is our nth term, or whatever we're talking about. So I think we know what all of these variables mean, so I think we can just kind of utilize this. So if I'm using this, let's go on 2 pages one more time here. If I'm using this to find S5, I think we already know the first 5 terms, so do we necessarily need to plug this into the formula? I think we can just add them together. So this is kind of what I was talking about yesterday with just like using your common sense. So we're just going to add these guys together. Whoops. And then we should get the sum of the first 5 terms. So negative 11, did I do that right? Yeah. Perfect. Okay, S13, I probably could write out the 13 terms and just add them together, but let's just practice using our formula here. A is negative 1, that's our first term. What's the multiple? What's the constant multiple? Negative 2, yep. We're multiplying by negative 2 to get future terms here. I'm putting that guy in brackets, you'll notice, especially this first one up here, because I am putting a negative to an exponent, and I want to make sure that I get the correct answer out of that, because if I put a negative to an even exponent, it's actually going to become positive. So here the negative will remain because it's to an odd exponent of 13, but I just want to be mindful of that. So we're just going to calculate here. I think we should get a whole number for this so we don't have to worry about leaving in exact values. So we'll plug that into our calculators. Okay, let me know once you've got it. Kylie's. The R is the constant multiple. So what'd you guys get? What'd you get?
Negative 2,731.
731?
Yep.
Did everybody else get this?
Yes.
Lovely. Okay. If you're using this formula, and let's say maybe your R value was a half or something like that, we're going to focus in on trying to use exact values again. So I know some of your calculators will do this for you. I'd like to see maybe a little bit of your work just showing that you know what's happening. But your calculators can definitely help you along the way with that. But we did some examples yesterday where we were working toward leaving those in like fraction form. So try to do that if you can. So just as a final thing here, I just want to quickly break down for you guys series and sequences and the difference between arithmetic and geometric. This is going to be a good little summary of the first half of our unit. So once we go to do some series problem-solving questions tomorrow, we'll have all of that in one place. Okay, we also, just so you guys know, we have a little quiz on your sequences and series stuff coming up on Monday. Okay, and then the following Monday after that will be the test. Okay, all right, so arithmetic versus geometric, series and sequences. Let's start with sequences. I think we're used to the sequences at this point. So arithmetic, we have a formula with n's and d's and tn's. And then for our geometric, we have Tn equals a times r to the exponent n minus 1. Okay, for our arithmetic series, we have 2 formulas. We have Sn equals n over 2 times 2a plus n minus 1 times d. And we also have Sn equals n over 2 times a plus Tn. The less used formula, I would say. Okay, and then for geometric, we have our Sn equals a times r to the n, all subtracted by 1 over r minus 1. Okay, so I want you guys to see if you can find some similarities between what you see in the geometric formulas and what you see in the arithmetic formulas. Maybe mainly this main one and this. And then what do we see as similarities with this and this for geometric? Like, how would I know just looking at these formulas that one is for arithmetic versus one something for geometric? Essay? Oh, okay. So anytime I'm working with geometric, I am going to see an R value. Okay? So although I'm giving you this formula but not labeling it, you guys should be able to use your knowledge of arithmetic and geometric and decide whether those formulas are for geometric or arithmetic, right? So here we see the R value and the R value here. That is actually telling us we're working with something geometric. What do you guys see with the arithmetic ones? The ends and everything, right? So that's not going to be a difference that we see necessarily. Joey? D, did you say?
Yeah.
Okay, that's right. So D value. The only one we don't see it in is this one, just because we've simplified this portion of the equation to Tn. But you should just know that this extra little guy here is arithmetic. Okay, so arithmetic, we want to think D value. Geometric, we want to think R value. How could I decide, if I'm just looking again at these formulas, how could I decide between which formulas are for sequences and which ones are for series? What do those things have in common? What's the difference between, the main difference between the formulas for both of the series and both of the sequence? Joey?
It's Sn equals
Okay, so Sn, you should be thinking series. Okay, or what we call this is we think sum. And for these guys down here, you can know the difference between a series formula and a sequence formula based on Sn or Tn. So Tn is actually telling us a sequence formula, or it gives us a term value. So we think term. Okay? So that's kind of our breakdown of what we'll be looking for sequences versus series, and arithmetic versus geometric.
You done?
Yeah, we're done, unless anyone has any questions.